about here this morning. Glad to be with you. It's a great opportunity to be part of this. Brent Black got me involved in orchard crops several years ago, and I thanked him. I'd been in agronomic crops all my life, and you can't get under the shade of an alfalfa field or eat from an alfalfa field like you can when you're working in an orchard. So this has been kind of fun over the years. But I've been asked to talk a little bit about soil management for fruit trees, and I'm focusing everything today mostly on apples and peaches. But at the end, I'll provide some resources where you can branch out into some specifics for other fruits as well. So with that, we'll move on. Just to give you kind of an outline of where we're headed this morning, we'll talk a little bit about soil preparation and planting, a lot about fertilization, particularly with respect to nitrogen and annual growth monitoring there. We'll also talk about the fact that you can't really separate irrigation and nutrient management. So we have to pay attention to the conjunctive management of both water and nutrients in these systems to optimize performance of our trees. And then a little bit about troubleshooting and salinity. I won't spend a lot of time on treatment or management practices because that's a whole entire discussion on its own, but we will talk about some basics here on it. So with that, let's get into soil preparation. We'll first talk on apples, then I'll switch gears to peaches as we go along. And anything that's different in peaches from apples, I'll point that out. But with apples and all fruits, when we get ready to prepare the soils, we want to ensure several things. Our fruits and vegetables, in particular of the plants we like to grow, are very intolerant of salt content in both irrigation waters and salt and soils. So we need to we need to know what our soil test levels are for those, so that we can plan accordingly in terms of what types of trees we might be looking at, or the varieties that are a little bit more tolerant of situations we may have with our soils. And it'll speak to some of the management issues as we get further down in the presentation here. Most of us are going to be dealing with soils between pH 7 and 8, maybe a little bit higher. And that's okay for most of the varieties of apples, peaches, and other fruits that we regularly grow here in Utah. They'll do just fine at those pHs, but we start getting into pHs above 8.5 or so, which can happen, particularly in our valleys. We have issues there with soil structure and infiltration and aeration, potentially with sodium issues in those soils. So we want to know where we're at there to make sure that we're going to be in a situation where our trees will thrive. Soil tests are also the very best way of determining our phosphorus and potassium fertility. Many of our other fertility status of the trees are better determined on plant tissue testing, but for phosphorus and potassium, really our soil tests are the best to monitor the status and the need going forward with those particular elements. So a routine soil test that you might get as you start out, preparing a small area for orchard trees, is to make sure you get a routine soil test that provides pH that we've talked about, the salinity that we've talked about, the soil texture analysis, and the baseline phosphorus and potassium fertility levels. With that information, we can begin then to determine what we're going to do to manage that soil going forward for optimal performance. In order to get the tree in the ground, these are more physical things than they are really soil management issues, but we want to make sure that we dig that hole large enough that we allow for those roots to explore the volume that we're placing them in. We want them to free up from the root ball. We want them to move out laterally and deep in the soil, but we don't want to bury the graft union on these. And so we want to make sure that the hole is dug 2 to 3 times wider than the root ball. That allows for that freedom of those roots to move out laterally and explore that that volume that they're being planted in easily, and no deeper than the height of the root collar, so that we don't bury that graft union below ground. And I'll show you a diagram of that in the next slide. You can amend the soil as you plant it, but make sure that you don't use any more than a ratio of about 1 to 3 compost to soil in the mix. The reason we don't recommend any more than that is that too high a ratio of bringing in a lighter textured material like a compost and mixing it in with that soil from the hole that you've just dug creates a textural discontinuity between the hole you've dug and the surrounding soil, and that can cause issues with water transport and movement of water out from the planting hole into the soil surrounding, and can begin to cause problems with the exploration of the roots into that surrounding soil, which over time you want in order for that tree to properly establish. But amendment is just fine with any of these, and you'll see this again in the peach discussion as we go along. Here's a diagram of the planting that I mentioned here. It's kind of 2 to 3 times wider than the root ball, and no deeper than the root collar, the graft union there above ground. And make sure that you kind of slope that soil away so that you don't get accumulation of water and other things near that graft union, because we don't want that particular area of the tree to begin to rot. It's not genetically designed to be below ground, and so we want to make sure that it stays dry to prevent any kinds of invasion of pests and other things that could be promoted if that particular tissue gets wet. And so we make sure that that's at ground level or above, and that the roots are free to then explore that hole that we've dug. And then we also want to make sure that where we're planting these, a lot of times in connection with turf, that we allow for some open area around the trunk. And this is more particularly important with peaches than even with apples. So with apples, it's recommended at least 18 inches away from the trunk of the tree, so that we can get moisture and fertility and other things specific to the tree introduced to that rooting area. In terms of fertilization, and we're going to change gears now from preparation and planting to fertilization. As I mentioned earlier, phosphorus and potassium levels are best determined by soil tests, and once those have been adjusted properly to the levels that we need, based on the recommendation that we get from the soil testing laboratories for that particular type of plant, the tree that we're planting, then we really only need to repeat those soil tests every 3 to 4 years to monitor changes in phosphorus and potassium. Nitrogen, however, is a different animal altogether, because it needs to be managed on an annual basis. Everything in the soil system, including the tree you just planted, is in hot competition for nitrogen. It's such a dynamic element in terms of need by all living things that we can't really rely on carryover from year to year as we do with potassium and phosphorus. So we base our applications on kind of a prescription application, and then monitoring annual new growth on the tree to determine whether or not we have sufficient nitrogen in the system. Excuse me. Younger trees, the recommendation is to begin feeding them with nitrogen, about a half cup of ammonium sulfate. That's a 20-00 fertilizer that you'll see available in all nurseries and other box stores and things like that. That's applied early in the spring near bud break, before the trees really leaf out entirely, so that the active uptake period will help pull that the nitrogen into the shoot and up into the leaves of the tree. We're not really concerned about monitoring new growth at those early years as that tree's establishing. We're going to be training it and pruning it heavily anyway, as we do normally for those first few years. But we want to make sure that there's sufficient nitrogen in the soil with that half cup of ammonium sulfate per tree for those first several years. Once they're established, then we really start basing our nitrogen application on annual growth monitoring rather than an annual prescription amount. You'll look at younger trees, beyond 4 years when they're begun established and starting to produce. We want to make sure there's enough nitrogen to support not only the production of the fruit, but provide for 12 to 15 inches of new growth. And we're not talking about water shoots that spring up from the internal parts of the tree. The ones that go vertical, those you're going to trim out anyway, but it's the growth on the ends of those fruiting branches that we desire to see. Older trees don't need as much annual growth. So only 8 to 12 inches. And if you have a dwarfed type tree, you're looking at getting away with maybe 4 to 6 inches of annual new growth. So we look at the annual new growth. If it's not at that level, then we increase the nitrogen application over the half cup per tree that's noted there for young trees. So for instance, if we have only half the growth, we'd want to double the nitrogen application in the next year and then monitor the new growth and adjust accordingly. So you're always looking at new growth from the previous year to kind of adjust your nitrogen applications going forward. It's recommended as you do get older in the production of the tree that you don't put any more than about 5 cups of ammonium sulfate application on an older tree. That would amount to about 7/10 of a pound of nitrogen per tree, and incidentally or coincidentally, that is generally about what is the recommended level of nitrogen application on an established commercial orchard, which is pretty typical. So we don't want to exceed that. If we do excessive nitrogen fertilization on our fruit trees, we can greatly reduce productivity because we're overstimulating shoot growth to the sacrifice of fruit production in there. So we want enough for fruit production, but we don't want to push the annual growth beyond the indicated levels that I've noted here. A lot of people ask us about micronutrients and micronutrient applications. Really, the most common micronutrient deficiency is iron in our soils because they're alkaline soils, and the alkaline condition just causes iron to be rather insoluble. We have lots and lots of iron typically in our soils, but the pH of our soils restricts its solubility. And so if we note a consistent, significant deficiency in iron, and we'll take a look at some visual symptoms of that later, we can correct that. Soil application is not particularly easy to do to satisfy an iron deficiency, just because there's so much going on in the soil chemistry that then begins to tie up that iron in the soil and make it less and less available to the plant. So if we do note those deficiencies showing up in the plant, we can apply an iron chelate solution to the foliage. This is done before the leaves are fully expanded in the spring. After that, there's not a lot of translocation that goes on in the plant anyway, so we want to make sure we're getting on when those leaves are beginning to expand, and we'll need it. Iron's an important component to chlorophyll and other things that are going to allow that plant to photosynthesize and produce properly. So foliar application can be done with either an iron EDDHA chelate, which is typically numbered 138 that you'll see on the product that's available for that, or iron DTPA solutions, which is a 330 solution. If you're applying it to soils, you want to restrict your use of chelate to the iron EDDHA form, which is more stable in alkaline soils. But for foliar application, you can use either. To spray on the canopy of the crop once or twice early in the spring as those leaves are beginning to open up and expand, so that we get sufficient iron. This would have to be, if you have a consistent deficiency noted, an annual application, because that iron will not be stored in the plant for subsequent years. It drops with the leaves. And so you'll need to make sure that you're addressing deficiencies that consistently arise on an annual basis with iron. Other micronutrients, we really don't see a whole lot of response to applications. Iron is really the one that we see the most and can be addressed the most effectively and efficiently. For phosphorus and potassium deficiency, if we, through subsequent monitoring of our soil conditions 3 to 4 years after we've initiated the planting, if we indicate a phosphorus and potassium need, we can use, rather than ammonium sulfate, a complete fertilizer, 1616 is noted there, or 1010, or other ones there to add the noted rate of nitrogen, but also carry phosphorus and potassium with that product into the root zone to correct those deficiencies. If a nutrient deficiency is suspected, really the integrator of all our plant tissue tests, they're the best integrator of need. And so if you suspect a consistent nutrient deficiency occurring and you want to address it, we would encourage you to submit a plant tissue analysis request to the laboratory of your choice. Typically, that's sampling mature leaves at the mid-canopy growth level on the tree, and making sure that you send in about 40 or 50 leaves to the laboratory for that analysis. I mentioned that I'd show you some pictures of iron deficiency. This is classic. If you haven't seen it before, I'm sure you'll see it. In most of our fruit trees, we'll have at least some portion of the tree that'll be experiencing some of this. Classic iron deficiency begins on the younger leaves. Iron does not translocate easily in the plant, so the youngest growth ends up showing the deficiency first. You get dark green veining in the leaf with yellowed intervein areas, very classic for iron deficiency in most plants. So in the extreme deficient condition, the leaves can begin to turn almost white with necrotic lesions showing up within the internal parts of the leaf. And in the extreme, the plant will actually shed severely deficient leaves from the plant. I talked about, or I mentioned anyway, excuse me, the importance of conjunctive irrigation management when it comes to optimum nutrient management control. Too much water, especially in the spring, can damage young root growth and reduces overall, even in starting with the foundational early growth in the spring, a reduction in both water and nutrient uptake, which puts the tree behind on that. In that early period when things are really beginning to break dormancy and beginning to grow actively, that's the most movement or translocation of nutrients that you'll see taking place in the tree. So we want to make sure everything's as healthy as possible. So waterlogged conditions can greatly change the chemistry of nutrient solubility in the soils, particularly with respect to things like our phosphorus. A lot of times in the spring, if we're getting too anxious and we're waterlogging or wetting up a colder soil early in the spring, phosphorus availability becomes restricted. And a lot of times we'll see the purpling of the leaf tissue. You can actually see a purple color begin to show up on leaf tissues where they'll be suffering from some induced phosphorus deficiency because of the chemistry going on in the soil. So we want to make sure we don't have waterlogged conditions, particularly in the springtime. And too little water overall reduces growth and uptake of nutrients and stresses the plant to a level that it just can't thrive. And so we want to make sure we have adequate moisture without waterlogging. It's interesting that we see in our high calcium content soils often calcium deficiency symptoms, things like blossom end rot on fruits, bitter pit in apples, and other things that are a calcium expression of a calcium deficiency. Generally, it's not the result of a deficiency in calcium in our soils or its availability. it's a water management issue. We get too much dry out between irrigations. We don't get deep enough watering in the root zone to help the movement of calcium from the soil to the root surfaces and facilitating the take-up of what should be ample calcium typically from our soils. Most apple varieties can be irrigated every 4 to 10 days, as noted by the seasonal variation in water need there. Where surrounded by turf, we need to focus in on deep watering around the tree every couple of weeks, because if we're just using a turf irrigation system to irrigate our trees, we generally don't get enough deep watering in those situations. You want to make sure that occasionally you get water down to that 2 to 3 foot depth. So deep watering in and around that tree trunk and the drip line of the tree will help ensure that we don't see things like that calcium deficiency I mentioned, or the restriction in uptake of other nutrients from the soil. We need to make sure that deep watering happens on those on a regular basis. Let's switch gears now to peaches. You'll see some of the very same things mentioned here. So where the things are different, I'll mention them as we go along. Peaches, similar to our apples. Apples are a little bit more tolerant of salinity than our peaches. And so we want to make sure, particularly with peaches, that we have low salt content in the soil and in the irrigation waters. I'll talk a little bit more about that with salinity toward the end of the presentation. Again, soil testing is really important to know where we're at with pH, salinity, P and K fertility, and so forth. The same issues with planting are relevant to our peaches as well. You'll see bare root a lot of times with the peaches, so we're making sure that we dig the hole wide enough and deep enough so that those roots aren't kinked or wound up within the area that we're planting, so that they can explore laterally and vertically through the soil as they need to. Again, make sure that you're not adding too much amendment there and causing a textural discontinuity. There are some nuances here with respect to fertilization and annual growth monitoring in the peaches compared to the apples. Again, phosphorus and potassium levels better determined by soil tests and adjusted every 3 to 4 years based on soil test levels. But with peaches, we need more annual growth in the older than 4 years monitoring. Again, a half cup of ammonium sulfate in those early years is enough to get the early establishment going. But we should be able to provide in later years enough nitrogen for production and up to 18 to 24 inches of new growth on the peaches. And again, we're not talking about the water shoots there. They'll spring up. We need to pay attention to those fruiting branches and things like that we're focusing on. Older trees don't need near as much, so they'll only need up to about 12 inches if of new growth. If new growth exceeds 24 inches, we do not add any nitrogen. We don't want to promote excess shoot growth. And so if we get more than 24 inches in the year previous, we will not add additional nitrogen in the current year. If less than 12 inches, we increase the ammonium sulfate to 1 to 2 cups per tree and adjust next season based on then the annual new growth there. So we're always looking at what happened the year previous in terms of the annual new growth, and adjusting our nitrogen application in the current year based on that, and then monitoring subsequent new growth as we go forward. I hope that that makes sense. It's not near as prescriptive as it may be for an annual crop. One of the things we've noted in our research is in our orchards is that the orchards that are regularly fertilized and attention is paid to this annual new growth monitoring and so forth, those orchards are by far and away more productive over the lifespan of the tree than those that occasionally receive fertility treatments based on maybe a perceived need or a visible need or deficiency that arises. And so annual application has, as we've seen, is critical to the optimal growth and performance of the tree over its lifetime. Again, with micronutrient deficiencies in peaches, the most common iron deficiencies, iron again, and we've mentioned the same treatment there on the canopy foliar applications of the different chelated forms. And again, we can use in subsequent years the need of for phosphorus and potassium, a complete fertilizer that includes both nitrogen and phosphorus and potassium. The same visual symptoms for iron deficiency are noted in peaches, again beginning on the younger leaves, the dark green veining and yellowed intervein areas. And with irrigation management, just like with the apples, it's critical to optimum nutrient uptake in those settings. Peaches do require a little bit more water than apples do. Excuse me, trying to keep my my throat and voice alive here as we go along. Requiring about 30 inches of water per season. Now, that's not just what you apply by irrigation, but that includes precipitation and previously stored soil moisture as well. So it's important that we don't overwater with our irrigation application. We take into account some of the other water that's available there. But if apple is co-located with a tree or with a turf, not apple, should say, as with apple, when peaches are co-located with a turf, we want to make sure that we actually open that area around the tree a little bit broader even than we did with apples. So 4 feet from the trunk in all directions, and occasionally then deep water to that 1.5 to 2 foot depth, so that we make sure that deep watering is occasionally utilized there. Peaches can go a little bit longer in terms of the irrigation interval if we're putting them in an ample application. In using a turf irrigation system, our irrigation intervals are often shorter than that. And so they may not water deep enough. So that increases the need for deep watering around the tree over the course of the season occasionally, to make sure that we're getting water down to that 18 to 24 inch depth on a regular basis. I've pulled a lot of this from our fruit production guides for small acreages. There's a very complex URL there that's listed for your reference, but it's easier if you just go to fruit.usu.edu, a very simple URL that we've designed there so that you can branch off into the small acreage section, the fruit section under small acreage, and then the production guides are available for all of the different fruits there. I also would point you to an additional online resource that I find really, really helpful. Montana State University has developed some nutrient management modules. You can just Google that phrase, nutrient management modules, Montana State University. And module number 9 in particular is really useful. It provides a decision tree diagnostic guide where you ask yourself certain questions about the symptoms you're seeing in the plant, and it'll guide you to maybe discerning a particular deficiency that might be there. And then, of course, if you think that follows the guide, the diagnostic guide, you can plant tissue test to confirm that need. And then, if you need help with interpretation of your soil test reports or your water test reports or anything related to nutrient management with your fruit trees, you can get a hold of your local agents, and the agents will get a hold of me if they don't know how to deal with a particular issue, and together we can kind of develop a management strategy for you. I did want to mention here, outside of nutrient management, salt management, because we in the Western United States deal with arid and semi-arid conditions where salts accumulate in our waters and soils. We have just naturally occurring soluble minerals in all of our soils and waters. But most of our fruit tree species are very sensitive to both soil and irrigation water salinity. We want our soil test levels in terms of salinity to be optimally below 1 to 2 decisiemens per meter. That's a measurement of electrical conductivity, which is a surrogate measure for how much salt is in the soil solution. Irrigation water tests, we want them to be optimally below 1 decisiemens per meter because the water concentrates when it gets into the soil and will create a higher level. So even preferably down in the 0.3 to 0.6 level with respect to irrigation water salinity. Salt injury really is more of an issue of restricting water uptake. As we have saline water in the soil, that salinity that's interacting with the water molecules in solution prevents it from moving across the root membrane and into the shoot. And so we want to make sure that we can provide for the removal of those salts if necessary, or keeping the soil at a water level and soil level or salinity level that will allow for the proper uptake. There is also the potential for some foliage injury on our plants. And so if you have a water of marginal water quality with respect to salinity, it could pose a sprinkling hazard. You'd want to make sure that you then convert more to drip or flood irrigation around the tree to prevent the saline water from contacting the leaves and shoot of the tree. One of the things people ask us all the time is how do I deal with salts? I emphasize that last point. Salts cannot be just neutralized with any kinds of additives that are out there that people promote sometimes for the neutralization of salts. They are ineffective, and so salts are typically the elemental constituents of the water and soil solutions. Those elemental constituents need to be removed, physically leached from the soil to provide proper conditions. And so developing a leaching strategy depending on your soil conditions and water quality available to you can be developed again with some local agent input on things. So just a picture quickly of our salinity injury symptoms. You'll see the necrotic tissue forming on the outer edges of the leaf. Is essentially a desiccation of the leaf that is a result of salt uptake and salt movement to the outer margins. And so with that, being able to identify that potential problem, I'll take any questions. I have been asked to provide this final screen for you for the conference. If you've got any Q&As, you can put them in the link, and there's other access to these presentations later on available through the diverseag.org website. So I think I'm right at time. Am I not, Ben?
You are right on the dot.
How about that?
Great. So we do have just 3 questions we'll go through really quick. Before we do that, just a plug for, we do have an hour break and then we have the afternoon session. This one's on water quality and irrigation and food safety. There's a lot of really good presentations and presenters. We have some from UDAF, some from the university, and some changes that you might be interested in across the state if you use secondary water or even culinary water. It'd be a great one to hit. Okay, for Grant, we have 3 questions so far. First one is, when applying ammonium sulfate to fruit trees, where is the best location to apply the fertilizer? Is it at the base of the tree, the drip line, or foliar application?
Foliar application is not a good idea with ammonium sulfate. It has a fairly high salt index, so we'd be worried about contact with the leaves. Within the drip line, younger trees, that would be closer to the trunk anyway, but anywhere within the drip line is adequate. And then make sure that you get that watered in. You want to water that down in. One of the concerns we have with ammonium sulfate in high calcareous soils is that if it's left on the surface, as it dissolves into its constituent parts, ammonia can be driven off as ammonia gas. And so we want to make sure we get that watered in. So apply it and then water it in with about 1/4 to 1/2 inch of water application to get it down into the soil.
Great. All right, then another question from Frank. Do the co-location limits for peaches and apples apply to clover as well as turf?
Turf would be a little bit more aggressive in its competition there for water and nutrient than a clover would be. But anytime you introduce weeds or a competing plant in the area, you can get some competition for both water and nutrients there. And because the nutrient needs and the water needs of the tree do differ from the surrounding plant, you want to be able to ensure that you're getting adequate both moisture and nutrient to the tree. And so that's why those setbacks and separations are recommended there. It's not so much that you have a problem with um, direct, like allelopathic or some kind of plant damage to the tree. It's the competition that we want to try to reduce there.
Okay. And last question, is the soil salinity measured utilizing an EC meter, or is there a different method used?
Yeah, there's several ways. An EC meter is typically what's used, and you can get a simple one, off of Amazon or at a nursery box store or something like that. They're not as accurate as it would be to send it in for a soil test, but you can get a pretty good measure from a handheld device on there. But typically, you want to make sure that you're properly wetting the sample when you take that measure. It's got to be at least saturated, and there's some nuances to making a saturation paste of the soil in order to measure the salinity on it. And so if it's not exactly where it is, you can, at saturation, you could greatly alter the overall reading. It may be too concentrated or less concentrated, and not reflect the real hazard associated with it. With a water sample, those EC meters are generally fairly accurate, and either EC or TDS measurements on an irrigation water, you can get a pretty good reading with a handheld device.
Okay. All right. And then since we're out of time, we have one last question. I think it's kind of a fun one. We'll end on this one from Grace. How beneficial would it be to have livestock and poultry grazing around the trees?
Well,
From a soil standpoint,
yeah.
maybe.
If you want to somehow credit the nutrient application you're getting from the waste of those animals, the only thing I would be concerned about livestock is goats or other things might browse the tree a little bit, so you've got to be careful of that, and girdling the bark and what have you. You wouldn't see that an issue typically with things like sheep or rabbits or other things, but you could get with even rabbits some damage around the base of the tree. So you don't want to compromise the bark protection at all with any kind of livestock around it. You wouldn't worry about that with the chickens. The only thing there is potential salinity buildup from particularly urine and poultry waste there. So make sure that you're getting plenty of water application to leach through some of that might be deposited within the drip line of the tree.